Okay, let's get going. It's 6:15. This is video 127, and as I told you, I'm going to be continuing on with this idea of factoring quadratic trinomials. Okay, so I worked out this problem here. I'm going to do this problem on the board, and then later today I'm going to follow up and do some more problems from the Regents book, and then I'll give you assignment with these guys as well. Okay, so let's get it properly focused here. Right here, where we see this, I'll box it, and the object is to factor this quadratic trinomial. Why is it different from the ones that we were doing before? The answer is immediate. I alluded to it many times. There's a 2 as a coefficient instead of 1. Notice in the next problem there'll be a 3, if you can see that over there, okay? So what I really mean to say is that when the coefficient's not 1, there's like an extra step, or it's not as obvious as it was when the coefficient was 1. Because the rule says you multiply the first coefficient by the last term. So you're just doing numbers. These powers really don't matter that much, as I'll show you down the road. So now the object is to factor this. Since they ask us to factor it, we conclude that it's factorable. Like I said many times, not all these guys are factorable. Most of them aren't. Something to keep in mind. Not everybody can be factored, but this guy can. So what's the rule? I multiplied the first term by the last term using only coefficients, and 2 times -3 is -6, as you see over here. So what's the combo that works? What numbers multiply out to -6 yet add up to 5? So it's the combination of the coefficients that really matters, no matter how complicated it gets, presuming one more time that it's factorable. Okay, so here I am now, and I found the key that works. I saw that 6 times -1 is -6. Now remember, it's not -3 anymore. It's 2 times -3. So 6 times -1 is -6. And at the same time, when I put them together, they add up to positive 5x. See, I broke it down? See how I broke it into 4 terms so I can factor the other 2 sides? See that? And it either works or it doesn't work. So now I go on to the next term down here. Okay? Trying to focus, and all I did is factor, as you were taught to do, monomial factoring. You were taught how to do that. I factored this guy, and there's the factorization. Did I make a mistake? Did I make a mistake? Just distribute, and you'll see that this is just rewriting this. So what did I get? What was the leftover that we talked about so many times? X plus 3. Well, if it's here, it has to be here. So I just wrote it out. Well, what number here makes this the same as this? Well, the -1. Distribute, you'll see that. I factored out the -1. -1, -1 times the 3, and I rewrote it out. So now the answer is going to be 2x minus 1 times x plus 3, as you see down here. The other way, since some kids think that it matters which way you break them up, I broke it up the other way. -1 times positive 6 is -6. -1 times positive 6 is -6. Where did I get -6? Where did I get -6? 2, excuse me, 2 times -3. There it is. Just doing it the other way around. Factor. You were taught how to do that. That's the factorization of this. What you do on one side, you put the same thing on the other side. If it doesn't work, it can't be factored. It's really that easy. What makes this work? The x plus 3. Why? 6x minus 3. I factored out the 3 from this term and this term at the same time, as you were taught to do. So both ways it works. And then if you look over here, I did a check on it, a more complicated way, because the obvious check is just to FOIL this right here. And notice, again, as you see through my work, that I just divided. I can't get a remainder. If I get a remainder, then it's not factorable. You should be able to see that now. And it works out. I get remainders of 0 whenever I do that. You were taught how to do that. That was last week. We were working on dividing and making sure we had no remainders. And there you go. Everything sort of ties up. This times this is that. You're done. Problem's complete. So I'm going to do one on the board now. Okay? And I'll get this stuff out of the way. You can always pause this, play over my steps, and now I'm going to do one that I wrote over here, so I'll move the camera a little bit. It's right on the edge of the board here. And I'm going to factor this one out. And I know it's factorable. They wouldn't ask me to do it. We'll talk more about factorable and non-factorable. But right now, we assume it's factorable. They wouldn't ask us to do it. So let's make sure we come up with the answer. Well, 3 times 2 is 6. I'm looking for the key that works inside of here. And the middle guy is -5. So the question is, what is going to multiply out to 6, add up to -5? But here we go again. If the first and the last terms are positive, and the middle term is negative, it must be a negative times a negative equals a positive. Because a positive plus a positive always must equal a positive. So I'm just talking what I was doing last time, the reasoning. So the only thing that works is -3 times -2 equals 6, and 3 and -2 equals -5. I found the key. Anybody else? Well, there's -1 and -6, but if you put those together, you won't get the same middle terms. Since these are the only dual factors of +6 that must be done by 2 negatives, then I'm done. It either factors or it doesn't. So we found the key. -3, -2. Let's rewrite. Go over here on the corner. So I rewrite this. I'm just rewriting the expression. I'll do it this way. If you like, I'll do it the other way as well. And this is just this. You should know that now. You should be able to see that and say, okay. So now I factor these 2 guys and these 2 guys and put them together. So the 3 factors out, the x factors out. What's left? X. And then this one is -1. Okay, that's what factored out. This is the same as this. Oh, it's got to be x minus 1 or it doesn't work. It's really that simple. Put it in parentheses. So what goes here in the middle that makes it work? Oh, yeah, -2. Watch. -2 times x, -2 times +1. So the answer is 3x minus 2 is attached twice to x minus 1. And the answer is complete. I'll do it the other way. I'll do it the other way, just so you get more practice. How are we doing on time? We're doing great on time. So it's 3x squared minus 2x minus 3x plus 2. Okay, so there I am, trying to avoid the screen as much as possible. And now I factor out what? Well, 3 and 2 are co-primes, so I have to factor out the x. So there's 3x minus 2. This is the co-prime. These are the remnants. These guys can't be put together. It's completely factored out. Oh, all right. So what's on one side has to be on the other side. Otherwise, it doesn't work. I keep saying the same thing. What number makes that go? -1. So there you got it. You got x minus 1 is attached to 3x minus 2. Okay? And since I came up with it twice in different orders, I'll assume that you understand what I did. So that's almost 10 minutes of explaining this stuff. I'm not going to check it. I'll let you guys do that. It's good practice. You'll be expected to do this kind of stuff next year. So later this morning, I'll make some more videos. At least another video. We'll have 3 up on the board, and I'll do all 3 out of the Regents book. And now you have a pretty good idea of what your assignment's going to be later today. Okay.